All right. Hey guys, so this is our warm-up for today. If you haven't written it down and solved it yet, or I should say simplify or factoring, please do so now. But if you have, let's get started. So x cubed minus 1, that's a difference of cubes. So we just remember our pattern, a, b, a squared, a times b, b squared, and then use SOAP. Same, opposite, always positive. The second problem does not have a GCF, so we're going to use our x method. 2x squared times negative 3 is negative 6x squared. Negative 5x goes in the bottom. Since negative 6x squared is negative, we're going to use opposite signs. The factors of negative 6 that add up to negative 5 are negative 6 and positive 1. So now we have 2x squared minus 6x plus 1x minus 3. Our first group has a GCF of 2x, leaving us with x minus 3. Second group has a GCF of 1, leaving us with x minus 3. So our factors are x minus 3 and 2x plus 1. Our last problem, that is a difference of squares. So our pattern is 3x squared, 1, 3x squared, 1. 1's a plus and 1's a minus. I can't go further with 3x squared minus 1 because of that 3. 3 is not a perfect square. Here are the answers to the homework from the textbook. So take a look at that. If you have any questions specifically on any of those problems, I want you to put a star beside them. Try to talk it out amongst yourselves. And if you're still confused, make sure you ask them from me when I get back next class. So next class, we will be having a quiz on solving logs and exponentials, but I will be available at the beginning of class to answer any questions that you might have. So we are, as this says, we're having, in the remainder of class, you'll have a review sheet on solving logs and exponentials. So our next unit is going to be on finding the inverse and the composition of functions. So today we're going to focus on finding the inverse graphically. All right. So first question is, what is an inverse? Inverse functions are functions that undo each other, and they're denoted as f to the negative 1 of x. That's going to be read as the inverse of f. Okay? A function if it is 1 to 1. So 1 to 1 means for every y, there's exactly one corresponding x. In order for us to decide if a function is 1 to 1, we're going to use the horizontal line test. All right, and what that means is you look at the graph. So let's say we have like kind of a parabola here. Well, if I put a horizontal line anywhere on there, I should only hit 1 point. Notice I don't hit at 1 point, so my inverse is not going to be 1 to 1. It's not going to be a function. Okay? However, if I look at, say, like our log function, if I put a horizontal line anywhere there, I only hit at 1 point. So my log function is 1 to 1, so its inverse will also be a function. All right? So here are some examples of some inverses of each other's. So our last unit was on exponentials and logs, and those are inverses of each other. So exponentials and logs are inverses. Quadratics and square roots are inverses, which makes sense. You undo a quadratic by taking the square root. And cube roots, which we dealt with in higher order, and linear and linear. They're inverses of each other, actually. Okay, so let's look at our first example here. So our first example, this is a linear function. Our question is there an inverse? To figure that out, we use our horizontal line test. Notice wherever you put a horizontal line on here, you only cross at 1 point. So the answer to that question is yes, because it passes the horizontal line test. So to find our inverse, it's really easy. What we do is we find pretty points. So here's my initial function. We'll say it's right here. This is my f of x. Okay. All right, and some pretty points are marked for us. We have negative 4, 0. We have 0, 2. And then we have 4, 3. Okay. So, or sorry, 4, 4. I apologize there. So 4, 4 is what we should have. So to get our inverse, that's going to be called f to the negative 1 of x, we just switch our x's and y's. So we have 0, negative 4, 2, 0, and 4, 4. So those are our coordinate points. So now I'm going to graph that function. So 0, negative 4, 1, 2, 3, 4. There's a point. 2, 0 is another point, and another point is that 4, 4. And now I'm going to take my straight line tool here, and you guys can do better than what I just did, but I think I should be able to move it. Yeah, there we go. And there is my inverse function. Okay, and the inverse is actually a reflection over this line, and this line that I am drawing right now is the line of y equals x. Okay. All right, so flip over to the back form. We've got 4 more examples. So we're going to graph, and we're going to state our inverse, and then we're going to look at the domain and range of each. So here's our initial graph. This is an example of a cubic. Remember, it's a spaghetti noodle. So its inverse is going to be a cube root. So look for pretty points, and there should be some nice ones marked for you. So some pretty points are negative 2, negative 9, 0, negative 1, and 2, 9. So our inverse function is going to have pretty points at negative 9, negative 2, negative 1, 0, and 9, 2. So negative 9, negative 2, negative 1, 0, and 9, 2. There's our points. We're just going to carefully graph that function. Notice that's a cube root. Okay, and again, it's been reflected over the line y equals x. All right, so our inverse is a function. So if you look at your original function, so f of x, the domain for f of x is negative infinity to positive infinity. The range is also negative infinity to positive infinity. For our new function, f prime of x, that holds true as well. And we'll start noticing some more stuff about the domain and range. So the domain and range aren't necessarily always the same, but in this case they are. So let's look at our second function. So one thing that we should notice in our second function is that this is a quadratic. It does not pass the horizontal line test, and because of that, we're going to get something that is not a function. So let's take a look at our initial function and write out the pretty points. So negative 2, 2, 0, negative 3, and 2, 2. So for our inverse, which I'm doing in green, is going to be 2, negative 2, negative 3, 0, and 2, 2. So 2, negative 2, negative 3, 0, and 2, 2 is our new graph of our inverse. Now, the reason this is not a function is because it does not pass our vertical line test. So it's going to hit your function at more than one spot. Therefore, our inverse is not a function. Now let's look at domain and range. So let's start off with f of x. So our initial function, the domain for that is negative infinity to positive infinity. The range, okay, the lowest it can go is negative 3, and then it goes on to positive infinity. Okay, now let's look at our inverse. The domain for our inverse, you'll notice, goes from negative 3 to infinity, whereas the range now goes from negative infinity to infinity. Notice that the domain and the range from the regular function flip-flopped in the inverse. Okay, let's see if that holds true in our next example. So our next example, this is an example of a square root. All right, so the inverse is going to be a quadratic. So let's take a look here at our initial function. Our initial function has some pretty points at negative 5, 0, negative 4, 1, and 4, 3. So our inverse is going to have points at 0, negative 5, 1, negative 4, and 3, 4. So let's graph those. So 0, negative 1, 2, 3, 4, 5. There's a point. 1, negative 4, and 3, 1, 2, 3, 4. So there's our graph. Now you're like, wait, it's a quadratic. Shouldn't I have another half of it? Well, yes. However, we're kind of restricting it a little bit right now. So it will end up being a function. All right, which it would have anyway. Sorry. So our initial function, the domain for our initial function went from negative 5 to infinity. The range went from 0 to infinity. Let's see if those flip-flop in our inverse. So if we look at our inverse, we'll notice that our domain goes from 0 to infinity. All right, the range goes from -5 to infinity. So the domain and range have flip-flopped. So our last function, okay, this kind of looks like an exponential. So, you know, or maybe a really wide quadratic. We're not really. But the initial function at, let's see, 0, 2, and 3, 4. So our inverse has some pretty points at 2, 0, and 4, 3. So 2, 0, and 4, 1, 2, 3. And they're going to be reflections. So it's going to look something like that. Okay, so initial function had a domain from what looks like -infinity to +infinity. And a range, it looks like from 0 to infinity, but it looks like there's an asymptote there. So I'm going to put a parenthesis as opposed to a bracket. Now my inverse is going to be the reverse of that, or that's what the pattern has been. So my domain, yep, it's 0 to infinity, and my range is from -infinity to infinity. So those are our notes for today. All right. Oh, sorry, one last thing. The bottom of our notes says domain and range inverse functions. So I wrote this for you. Domain and range are switched, which makes sense because we switched our x's and y's. All right. So what I want you to do, all right, is to complete the review sheet to help you prepare for our quiz next class. And then I'm going to go over all the answers to that review sheet at the end of class. Well, the video will anyway. Have a good one.